Venus no more, a super-Earth takes its place. Our solar system is a delicate dance of gravity. Each planet, from tiny Mercury to giant Jupiter, exerts a gravitational pull on its neighbors. This cosmic ballet keeps everything in its place. But what if we change the dancers? Imagine swapping Venus, the searing second planet, with a super-Earth. Super-Earths are planets like ours, but bigger. Much bigger. They can be up to 10 times more massive than Earth. Now picture a super-Earth right where Venus used to be. This is no mere cosmic switcheroo, it's a game changer for the entire solar system. The gravitational balance is thrown into disarray. Earth and Mars, Venus's closest neighbors, would feel the brunt of this change. The super-Earth's powerful gravity would tug at them, altering their orbits. Earth's year might lengthen, and its seasons could become unpredictable. Mars might be drawn closer to the inner solar system, its icy surface thawing under the increased heat from the sun. This hypothetical scenario, while extreme, allows us to explore the fundamental forces shaping our universe. It underscores the interconnectedness of celestial objects and how even a slight change in one part of the solar system can ripple outwards, affecting everything else. It's a cosmic game of dominoes, and the stakes are astronomical. Section 2, Gravitational Upheaval. Earth and Mars feel the pull. The introduction of a super-Earth into Venus's orbit would be nothing short of a gravitational earthquake. Imagine a celestial bowling ball thrown into the middle of our well-organized solar system. The gravitational effects of this super-Earth, significantly larger and more massive than Venus, would be felt most strongly by its immediate neighbors, Earth and Mars. Earth's once stable orbit would be perturbed. The super-Earth's gravity would tug at our planet, causing a wobble in our orbital path. Our year, the time it takes for Earth to complete one orbit around the Sun, could lengthen or shorten, throwing our calendar into disarray. The tilt of Earth's axis responsible for our seasons might also be affected, leading to more extreme or unpredictable climatic variations. Mars, further out but still within the super-Earth's gravitational sphere of influence, would undergo its own set of changes. The red planet's elliptical orbit might become more elongated, pulling it closer to the Sun at times and flinging it further away at others. This would lead to dramatic temperature swings on the Martian surface, potentially impacting the stability of its polar ice caps. The asteroid belt, lying between Mars and Jupiter, wouldn't be spared either. The super-Earth's gravity could stir up this collection of space rocks, potentially sending some hurtling towards the inner solar system. While a collision with Earth is a remote possibility, the increased gravitational jostling would undoubtedly raise the risk of asteroid encounters. Section 3. A world-transformed super-Earth surface and skies. Let's turn our attention to the super-Earth itself. This new resident of the inner solar system would be a world unlike any other, shaped by its immense size and proximity to the Sun. Imagine a planet with a surface area many times larger than Earth's, dotted with towering mountain ranges and vast, deep oceans. The super-Earth's interior would be a place of intense heat and pressure. Its core, likely a churning ball of molten iron and nickel, would generate a powerful magnetic field, shielding the planet from harmful solar radiation. This magnetic field would be far stronger than Earth's, extending far out into space and potentially affecting the behavior of the solar wind in its vicinity. The atmosphere of this super-Earth would be equally impressive. Due to its strong gravity, the planet would retain a thick, dense atmosphere, potentially composed of gases like nitrogen, carbon dioxide, and water vapor. This atmosphere would be a key factor in shaping the planet's climate, trapping heat and potentially creating a runaway greenhouse effect. However, the exact composition of the atmosphere would depend on a multitude of factors, including the planet's formation history, volcanic activity, and potential for harboring life. Studying this atmosphere would be a top priority for astronomers, providing clues about the planet's past and present conditions. Section 4. Shifting atmospheres, global winds and weather patterns. The atmosphere of a super-Earth wouldn't be a static, uniform blanket of gas. Instead, it would be a dynamic, ever-changing system, driven by the planet's rotation, heat from the sun, and the distribution of land and water masses on its surface. Imagine a world with winds that make Earth's hurricanes look like gentle breezes. The Coriolis effect caused by the planet's rotation would play a significant role in shaping global wind patterns. On a super-Earth with its likely faster rotation rate, The Coriolis effect would be even more pronounced, leading to powerful jet streams and potentially influencing the formation of massive storm systems. The distribution of continents and oceans would further complicate atmospheric circulation. Large land masses would heat up and cool down more rapidly than the surrounding oceans, creating temperature differences that would drive wind and weather patterns. Imagine vast deserts baking under the intense sunlight while towering thunderstorms rage over the tropical oceans. The composition of the atmosphere itself would also influence weather patterns. A dense atmosphere with a high concentration of greenhouse gases could trap heat, leading to a warmer planet overall. Conversely, the presence of certain aerosols or cloud formations could reflect sunlight back into space, potentially offsetting some of the warming effects. Section 5. A restless giant volcanic and tectonic fury. The interior of a super-Earth wouldn't be a place of peace and tranquility. Instead, it would be a realm of intense heat, pressure, and geological activity, shaped by the planet's massive size and gravitational forces. Imagine a world where volcanoes dwarf Mount Everest and earthquakes reshape entire continents. The planet's core, a churning inferno of molten iron and nickel, would generate vast amounts of heat. This heat would rise towards the surface, driving convection currents in the planet's mantle, the layer between the core and the crust. These convection currents would, in turn, exert tremendous forces on the planet's crust, breaking it into massive tectonic plates. The interaction of these tectonic plates would be a sight to behold. Imagine colossal collisions, where continents crash together, pushing up mountain ranges that pierce the sky. Imagine deep ocean trenches where plates diverge, allowing molten rock to well up from the mantle, creating new crust. Volcanic activity would be another defining feature of this super-Earth. Imagine colossal volcanoes dwarfing anything found on Earth, erupting with unimaginable fury, spewing lava, ash, and gases into the atmosphere. These eruptions could have a profound impact on the planet's climate, potentially triggering global cooling or warming events, depending on the composition of the erupted material. Predicting the climate of a super-Earth is a complex and challenging task. Multiple factors, including its distance from the Sun, atmospheric composition, volcanic activity, and the distribution of land and water masses, would all play a role in shaping its climate. Imagine a planet where the line between habitable and hostile is constantly shifting. One possibility is that the super-Earth, located in Venus's former orbit, could experience a runaway greenhouse effect. Its thick atmosphere, rich in carbon dioxide and other greenhouse gases, could trap heat, leading to soaring surface temperatures that would make Venus seem balmy in comparison. Oceans could boil away, leaving behind a parched, desolate landscape. However, other factors could mitigate this extreme scenario. The presence of clouds, for example, could reflect sunlight back into space, cooling the planet. Additionally, the planet's rotation rate and axial tilt would influence the distribution of sunlight, potentially creating more temperate zones. The presence of life, if it were to exist, could also have a significant impact on the climate. Photosynthetic organisms, for example, could absorb carbon dioxide from the atmosphere, potentially offsetting the greenhouse effect. Conversely, the metabolic processes of other life forms could release greenhouse gases, further warming the planet. The possibility of life on other planets is one of the most profound and enduring questions in science. A super-Earth, with its diverse geology, potential for liquid water, and thick atmosphere, offers a tantalizing target in the search for extraterrestrial life. Imagine a world teeming with creatures unlike anything we've ever seen. However, life on a super-Earth might not resemble life as we know it on Earth. The higher gravity, different atmospheric composition, and potential for extreme environmental conditions could favor the evolution of organisms with unique adaptations. Imagine creatures with dense skeletal structures, adapted to withstand the crushing pressure, or organisms that thrive in environments toxic to Earth-based life. The search for life on a super-Earth would require innovative approaches and technologies. Remote sensing techniques such as spectroscopy could be used to analyze the composition of the planet's atmosphere, searching for telltale signatures of biological activity such as methane or oxygen. Future missions could deploy probes or even robotic explorers to the planet's surface, searching for direct evidence of life in the form of fossils, microbial mats, or even extant organisms. Discovering life on a super-Earth, even if it were microbial, would be a monumental event in human history. It would demonstrate that life is not unique to Earth, but rather a fundamental process that can emerge and evolve under a wide range of conditions. It would provide invaluable insights into the nature of life itself and our place in the cosmos. The discovery of a super-Earth in our solar system would ignite a new era of space exploration. Imagine a future where robotic probes and human missions venture to this alien world, seeking to unlock its secrets. The scientific potential of such an endeavor would be immense. Robotic missions would pave the way, deploying landers and rovers to study the planet's surface, analyze its atmosphere and geology, and search for signs of past or present life. These robotic explorers, equipped with advanced instruments, would act as our eyes and ears on this distant world, beaming back a treasure trove of data. Human missions, while more challenging and expensive, would represent the ultimate goal. Imagine astronauts setting foot on a super-Earth, exploring its vast landscapes, and conducting experiments that would be impossible to perform remotely. Such missions would capture the imagination of the world, inspiring future generations of scientists, engineers, and explorers. The technological advancements required for such missions would have far-reaching benefits, pushing the boundaries of aerospace engineering, robotics, and materials science. New propulsion systems, life support technologies, and radiation shielding would need to be developed, paving the way for even more ambitious space exploration endeavors. The hypothetical scenario of a super-Earth replacing Venus, while purely speculative, offers a valuable thought experiment. It forces us to confront our assumptions about the cosmos, the diversity of planetary systems, and the potential for life beyond Earth. Imagine a universe full of possibilities, where our solar system is just one of an infinite variety. The discovery of a super-Earth so close to home would challenge our understanding of planet formation and evolution. It would raise questions about the prevalence of such planets in other star systems and the potential for them to harbor life. It would underscore the vastness and diversity of the cosmos, reminding us that our own solar system, for all its wonders, is just a tiny speck in the grand scheme of things. More importantly, it would serve as a powerful reminder of our own cosmic insignificance. In the face of a super-Earth, our own planet, with all its complexities and challenges, would shrink in comparison. This realization, far from being disheartening, could inspire a sense of awe and wonder, fostering a greater appreciation for the fragility and interconnectedness of life on Earth. Ultimately, contemplating the hypothetical can lead to a deeper understanding of the real.